Hello, everyone. I hope you're all having a great day and are excited for today's workshop, the fourth session in the Rootstock Educate. Today, we will be having Marcus from the Graph, and he will be giving his workshop on getting started indexing rootstock data with the Graph. I hope you guys are excited. I'm just inviting him on stage. Hello.
Hello, how's everyone doing?
Good, good. Whenever you're ready to share your slides, the stage is all yours.
Hey, all right, everyone. I'm gonna go ahead and share my screen, and I'll be looking at the chat the whole time. So if anyone has any questions as I'm going along, feel free to just drop something in the chat, and I'll be happy to jump in. So let's move the chat window actually real quick. Here, there we go. Multi-screen for the win. Okay. Can everyone see the presentation window from Google Slides? It looks like I can see everyone. Yes. All right. Hello, Arcadio. Hello, Jumaru, GMGM. Okay, so let's get into it. Hi, everyone. I'm Marcus. I work as a DevRel for Edge and Node, which is a core development team working on building the graph. So if anyone here doesn't know what the graph is, we're going to go through a quick kind of introduction to the graph and understanding what the use case is for the graph. And then from there, we're going to go ahead and see how to use the graph in your day-to-day and building. And then also, or even a little one step deeper, actually build some of the tech that is part of the graph, which is a subgraph when we do that. So View 10, you develop in Solidity, know nothing about the graph. That's okay. I will be talking directly about Solidity in just a second, so we'll be on the same page with it. So yeah, anyone has a question, feel free to drop in the chat, and here we go. So if anyone wants a link to some drag and drop query code that essentially allows you to use vanilla JavaScript, Python, Apollo, or a library that the graph has built called the Graph Client, it is a way that you can just go ahead and start querying blockchain data with the graph very quickly. And so just wanted to throw this out there right away. There's another repo that I'll be sharing in the next slide as well. Right here, this is another one with the QR code. This is built by another developer on our team. More front-end frameworks, whatever you'd like to use to query the graph, you are able to with these two repos. So I'll go back for one here. And if anyone wants to scan this, feel free. 3, 2, 1, and then I'll go here too. So those are the two. I will also be sharing this workshop at the end in case anyone missed either of these. Any Rust on the horizon? I am not aware of Rust on the horizon at this time. So good question. Is it the GraphQL for Web3? It uses GraphQL as the query language for Web3. Great question. There are other ways to query beyond GraphQL, and that is an option. But right now, yes, GraphQL is a great way. So into this presentation. It's not the answer that enlightens, but the question. I like this thinking. Anytime I'm building, I like to think, okay, like what am I curious about? What do I need to solve? What's the question I have in my head? And then what are the tools in front of me to solve the question that I haven't had, or to find the answer to the question. So it's the question is always to me more interesting than anything. And then from there, we can go out and solve or at least answer the question. So let's go into essentially the curiosity of things, and then using the graph, we can solve that curiosity and get some good information from blockchains. So real quick background, 1, 2 here. The blockchain, as we all know, is write optimized. We're able to write a lot of information, a lot of transactions onto the blockchain, store information like crazy with our smart contracts. It's awesome. However, it's horribly disorganized. And if we are to look at any singular block, go ahead and look at the Rootstock, block explorer, and look at any one block. It's coming from, hundreds of different smart contracts at any one time. So any one block is just not organized well, and it makes it not very performant. If anyone wants to go ahead and look through a block explorer for any amount of time, it becomes quickly evident that it's not the most optimized for speed. It's just records, and records are great, but when you want to have a performant front end, just having a big bucket of records organized by timestamp is not the best way to do it. We have to actually organize the data in a way that is performant, and then from there we can develop some cool stuff. So how do we organize that? How do we organize the data in a way that can be read quickly and done in a way that is performant? Well, we could do that organizing the data with indexing. And indexing had a few different options, just like a blockchain. There's levels of centralization with different blockchains out there. With indexing, there can be very much a centralized indexer, where there's one indexer that's providing all of the data from any blockchain. And that becomes a problem, because essentially you're taking the performant aspects of the data science that you'd like to gather and making it just narrow, bottlenecked into one indexer. And essentially you have all the same problems that we've been trying to get away from in Web 2. You have vendor lock-in, you have potentially extractive prices, you have all these other things that are problems with centralized indexing. And the graph is the option for decentralized indexing, where there's 100+ indexers that are permissionlessly indexing and organizing all of this blockchain data around the world, and they're doing it in permissionlessly. They're doing it incentivized by GRT, which is our token that we have in the graph. And by them doing the work that they is technical, that involves organizing data in a way that we'll get into in a little bit, they're paid. And that's a really cool thing. So you're not going to have vendor lock-in with the graph. When you go ahead and use the graph, it's a competitive marketplace where all of these indexers around the world are organizing their data and doing it competitively against each other in a marketplace. So when you send a query to the graph, you're trying to have that query go through a system of indexers that each want to provide you the best service for the cheapest cost. As opposed to if you just simply hire a single centralized indexer and you get locked in, well, then they could raise the prices and you're kind of screwed. So that is the graph. It's a very Web3 solution for a problem that if we want to have performant front ends and actually gather that data from the blockchain in a quick way, it should be decentralized. And that's the graph. So let's go into a little bit of data here. Like I said, this is a little bit more about the graph here. Let's see. I'd be curious in case the graph can monitor and subscribe to Solidity events. Oh, you're in luck, view 10. Yes, that is exactly what the graph and subgraphs do. Subgraphs, we'll get right into that right now. So subgraphs essentially are customizable APIs. I'm going to show everyone here how to build one of these subgraphs or customizable APIs. And they really connect all of these indexers right here. And we can build these little arrows right here. We can build how the data is being extracted from these indexers, and we can tell these indexers, hey, we want to organize this data in this very specific way. If you could give me an API endpoint to send our queries to, I'm good to go. I can build my front end, I could have a performant dashboard, I could do analytics, I could do a lot of cool things, and I can do it from any one of these indexers, or 2 or 10 or 15 different indexers, so there's lots of redundancy. If any indexer goes down because their power goes out or whatever, there's a major storm, there's many others backing them up, and that's another thing that the graph can do, which is pretty powerful. And also, not only are these indexers in a marketplace, but subgraphs themselves, there's another marketplace. There's a marketplace around these subgraphs, and there's a marketplace around these indexers. So there's a lot of competition baked in to make sure that things stay cheap. So that's really important. And so for those visual learners out here, this is a very good subgraph visual, I think, live footage of subgraphs in action, essentially taking disorganized blockchain data from over 70 different chains right now and putting them into a database. And those databases exist in the graph nodes, which are these indexers. These indexers are running software called Graph Node, and they reside here. All these databases are here. You don't have to manage them. You don't have to house them. You don't have to have big old stacks of storage. It's all housed here and organized here. And then from there, you just have an endpoint and send that query and you get it back to yourself. So it's pretty cool. We're going to get into this building in a little bit. And just to introduce, I'm seeing Mateus W typing. I'll answer your question when you hop in. We'll get into this as we build a little bit. There's the 3 main files for any subgraph. You're going to have the manifest. It's known as the manifest. It's the subgraph.yaml. You want to think of this as the high-level overview of the subgraph that simply names where the subgraph is, what chain the subgraph is going to be on, what smart contract or smart contracts is going to be indexing. It just names the things from a high level overview. Then there's the logic. Then, okay, well, we've got those smart contracts events being emitted from the smart contract. Do we just want those events to go right into the database and just the data as is? Or do we want to do some transformations? Do we want to do some mathematics? Do we want to go ahead and do some taking data from one event and bringing it to another event and then combining it to a customized entity in our database? Do we want to do some interesting stuff? Absolutely possible with the transformations and the logic. And then finally, the organized data. That's the database right in there. So this is how I like to look at a subgraph, from high level to medium level to low level. You extract, you transform, and you load right in there. So that is kind of the flow right in there. So would it be feasible to use the graph to make a subgraph for time series data? There is a new feature called time series and aggregations that was just released. And actually, now that we're just here, series, let's go ahead. Graph protocol GitHub. This was released, here it is, few months ago, and essentially this is awesome. I've used this a few times in a few of my subgraphs, and it allows compute over set amounts of time. Right now, hour and day are the only two supported, but that eventually will be more. This was just released, and it's a really cool feature. It allows for compute on regular intervals, and that's so helpful for just having a useful dashboard without having to run into lots of complex things all at once. So yeah, right now, sum, count, min, max, first, last are available. And also the aggregation expressions where you could do those in there. So play around with that if you want to go into like really easily doing compute, and you don't have to do anything really fancy. Like the entire code really looks, it's very sexy, very short. Whereas this is all you got to do. All you have to do is make a time series entity, and it's got to also have an aggregation entity, and that's it. It's very plug and play. Is it for moving averages or so? Eventually, it's going to get there. That's the plan, because you can see where this goes. Like right now, it's starting with sum, first, last. I think there's averages, maybe. Read through the docs. It's coming soon. So right now I'm presenting live, so I'm not able to read this because that would be rude to you guys. But yeah, stay tuned for this, for averages, for all this mathematical stuff. The graph node team, this is what the indexers run. So the indexers out there, they run this software, and all this mathematics is done on their end. All you got to do is write the API to tell them to do the computations. So anyways, cool little question to go into a tangent. Let's keep on going. Good questions. So I did say also subgraphs are valuable. Let's just go into that. www.graph.com Explorer. And this is where the marketplace is for subgraphs. And each of these subgraphs have a certain amount of GRT on them. I'll make my screen a little bigger. And this GRT essentially is a stake that people can do to say, this subgraph, this API right here, has organized the data in a useful way. And there's a lot of queries. We have 321,000 queries going through Snapshot. We have 2.6 million going through Quick Swap. So these are highly in-demand subgraphs. And when there's GRT put on there, and there's a lot of queries at the same time, staked rewards increase. So it's a really cool thing where people can identify more valuable data pipelines, and then from there get returns on that. And that's a cool little option for people who want to dive into more layers of the graph. But I'm going to the tokenomics. Let's not worry too much about that. Let's say any one of these subgraphs out there, we say, hey, I want to look at how LivePeer is organizing their data. And not only do I want to look at it, I want to go ahead and really dive into the data. And I can do that. If you go to the Graph Explorer, we're looking at a subgraph right here. And each subgraph, like I said, has an endpoint. There it is. Boom, right there. We can send queries to this endpoint, and there's example usage, React, Next.js, Node, are shout out to the product team who I know a few of the guys in the product team, they do a very good job putting this together to make things really easy. But yeah, essentially you have your query URL. You'll get your API. You want your API key. Only Rust missing in there. I hear you. I understand Rust is the future, and we understand that too. So we're very aware of building towards that. So your API keys in Studio. So set up an API key. You'll just drop it right in there. 100,000 queries per month are free. So go ahead and just play around to your heart's content before. And after 100,000 queries, it's $40. I think it's $38 in the market right now per million queries. So really competitive pricing should you be going from development to production. So very, very affordable. So yeah, this is GraphQL. In case anyone doesn't know what GraphQL is, and the entities in the database that LivePeer is using, they built all of this on a subgraph, and we're going to go into how to build a subgraph in a minute, but right now this is just the end result of a subgraph. You could send a query and get data back, and this is live data coming through, and we've already built that query, and we can go ahead and add more information just by clicking around and just having some fun. Send another query. Once we've designed our query right there, and we can see that we have saved a few different queries that are in our history, we can go back and see what we're doing here. We want this query, beautiful, and then we just simply send it to this endpoint with our API key. It's very well done. Shout out to the product team. They're awesome. So any questions, keep on dropping them in the chat, guys. Good chatting with everybody. But this is essentially how to use the graph if you don't want to build a subgraph. Like, that's totally fine. You don't have to build a custom API because there's already 10,000 subgraphs on the Graph Explorer right now that are publicly available, Rootstock included. So there's many subgraphs all over the world, indexed all over the world. And if you are thinking, hey, I want to index like Lido, there might already be a subgraph out there that has already organized it and been extended to the point where it is a robust, beautiful subgraph with a lot of different useful compute inside that you don't have to build from scratch. So I would recommend anyone here that wants to see, has anyone put in the work out there in this open data space? Go see if someone has put in the work to build a substantial subgraph. And then from there, if they haven't, then go ahead and build that subgraph. I'd recommend that for anybody. Also, of course, if you're deploying a custom smart contract of your own or your team's, and you are in control of it, it's very likely, of course, that no one's built a subgraph for that yet because you guys just built that thing. So that's what we're going to head to right now. We're actually going to say, hey, I've written a smart contract. I want to index all the events. And the subgraph is, of course, not built yet. I haven't built the dang thing because I just deployed the smart contract. So that's where we're going to go ahead right now. I'm going to go back to my slides real quick, see if I've missed anything because I'm just chatting away without looking at my slides. Yes, so we did the we're setting up an API key. That's very easy. We assessed a subgraph on the Graph Explorer, just took a look at it and said that was good. Designing some queries in the Subgraphs Playground, that's available too. And then integrate the query with the DApp. That query that we did right there, I showed you how to do queries, and then from there, this QR code can just literally take that query that you saw in GraphQL and drag it into these frameworks and replace, of course, the endpoint and then go from there. So that is awesome. Let's go a little bit deeper into this because what I did before, I see a question here. So I'm looking at the chat. Where's the chat here? There we go. Is the cost relative only to the end result data, or it has to do with the total index data of a contract? The cost I was talking about, the $40, $38 to $40 right now per million queries, is just per query, and it's just a flat. That's it. It's 0.00 something, per query. I think that answered your question. If that doesn't answer your question, I apologize. But yeah, it's just the marketplace. Which Ethereum testnet has subgraphs, Gurley, whole sky. I've been on the company for multiple years right now, and there have been subgraphs on all of them. What I would recommend is just simply going through and just go ahead and look for subgraphs on any of them. I know Gurley, deprecation, Sepolia, they still exist because people built on them in the past, and that data still exists, but it might not be being updated. So yeah, go play, go see what's available out there. Because in my time, there's been many different chains that have been deprecated, testnets at least. So probably not possible. Is there, what time would it be great to know a little bit more about the network itself, node and data providers? Sure, ask any specific questions and I'm happy to answer those questions, Mateus? If there's, I have an hour booked starting at 12:30 my time, and I go into 1:30. So I'll do one more question before we go a little bit deeper into subgraphs and the code itself. Yeah, V10. If you have a smart contract out there that you have built or your team has built, absolutely, you need to build your own subgraph to index the events and to put them in organized buckets to have an API attached to those to that database. And if there's another smart contract out there that even you didn't build, but you are curious about the events and there's no subgraph attached to it, absolutely do that. And also, even if there is a subgraph attached to it, you might want to transform the data in a unique way that the currently existing subgraph is transforming in the way you don't like, and you want to extend it and have more features and do more things to that data. Oh, there's a question in the question box next to the chat. Oh, thank you. There we go. Yes, we will build a subgraph now. Yes, we will. One more question. Can you give us an example of utility of the graph querying blockchain, querying in blockchain? Yes, we're going to do that right now. Okay, great question, Hassan. We're going to go ahead and drop questions in the chat. Let's go ahead and build a subgraph and look at the code and then compare that subgraph, our baby beginner subgraph, to an extended subgraph. And both of the subgraphs will be indexing the same smart contract. So we can see what a baby subgraph looks like. And then we can look at a subgraph that has lots of features attached to it. And that's a really good way to learn, because you can compare a baby one to an extended one, and you guys are smart enough to fill in the in-between. So what I like to do is go back to when I first started building subgraphs and understanding the graph. I was curious about the data through CryptoPunks. I was interested in NFTs. And so I remember going to the graph and saying, okay, well, I want to get the data. What do I do? And so I remember going here and seeing specifically this subgraph here from, I don't know, 2-3 years ago. And this is the same one. It might not have all the most recent features that are out there today, but it does have much more extensions to the features that a baby subgraph has. So it's still quite useful. So with this subgraph, what we can do is, I'll get to your questions. Keep on dropping them in the chat, guys. I promise I'll get to them. Keep on dropping them. I'll go back. If we go to the About page, we can see there is a GitHub. And every one of these subgraphs is permissionless. Anyone can build them and anyone can make them public. That means anyone could have great documentation or terrible documentation of their subgraph. It's open market. So this developer here has done a very good job linking to their GitHub, showing the manifest, which helps us understand from a high level what they're doing, and then also has the token ID of that subgraph as well, which is all very helpful information they've put in there. Also, just for the sake of this, we can see there are 3 different indexers around the world that are indexing the subgraph. So if any one of them go down, basically you want to look at these like a little company, like an indexing company. There's 3 companies indexing this subgraph. So if any one goes down, that's a huge advantage. And that's the competition I was talking to you about earlier. So let's go a little bit into the code here and just take a look at just introducing what a subgraph is. The 3 main files, we have the subgraph.yaml, and we're going to start with this. Essentially, the subgraph.yaml, like I said before, is a high-level overview of the subgraph. And here we have a subgraph for the CryptoPunks marketplace. They have a description. This developer has put in the repository, linked into the subgraph database itself, which is located in the file system, and that's right there. And then here's the data source. It's actually getting it from the CryptoPunks smart contract, the one that ends in BBB. We have a start block where the subgraph will start indexing from. Typically, you want to choose the start block where the smart contract was deployed. You don't want to do the start block of 0 if the smart contract isn't there, because it'll take you a long time to get all the way up to the start block. So I'll show you how to find the start block of a smart contract with a app. We're trying to get the app to be more integrated into our platform, but some hacker built it and I like it. So anyways, and just simply names the entities, which are things in the database. These are the way the data will be stored in the database. And then it names the event that the event handlers that are in the subgraph. I'll make this a little bigger for everybody. And so I want to connect the entities in the database to the event handlers real quick for everyone. Notice the event is emitted. Let's do a little narrative here. The event is emitted from chain, and we're going to call this the assign event. And there's the event signature that goes over there. When the event assign is emitted from the smart contract, the handler is triggered. Boom, it's triggered. And this is where the transformations occur. We'll go into that in just a second, but just think high level right now. Excuse me, getting over a cold right now. Still have, oh, I'm filled up with lots of sinus things right now. So the assign event is emitted, and then the handler is triggered. And then once this completes and returns data, it'll send it over into the assign entity. Do they have an assign entity? They don't. That's interesting. So this developer has not made an assign entity in the database. Have they made a punc transfer? Let's see. Transfer. Here we go. This is an easier one to see. This is a custom subgraph, remember? So a lot of people will just literally take the assign event, put it to a handle assign handler, and have it end up in an assign entity. And it's a one-to-one movement of the data. This developer did not do that. But likely with this transfer one, more of the same. So there's a transfer event, triggered the transfer handler, and then from there, it likely will end its data into the transfer entity in the database. Now, because there is transformations in this event, in this handle transfer function right there, we have to dive into that. We have to, like, what's going on? Are they taking the data and pushing it right into the database, or are they doing some mathematics with it? Let's dive a little bit deeper and find out. So that was the subgraph.yaml. Let's go back and we'll go into the source folder and we'll look at these. Anything in the source folder are the mappings. That's where things are doing the transformations. So let's just go into the, let's say mapping.ts, and we can see all of these handlers. Let's go down after the imports. Here we go, handle assign. That's something that I took a look at earlier. That's a handler right there. You can see this person's doing a lot of different transformations. I'm not going to go into all of them, but just understand this is the handle transfer right there. Cool. So a token transfer comes through, it triggers this handler, and then this runs. It goes all the way through, and it stores this information into these three entities. We have a C token entity, to account, from account. This person's doing more. Essentially, you want to look at this extended event right here as this event handler as the top. When the function is defined, you have an event that is the trigger for this function to fire. Once the trigger occurs, you grab all the data and you decide what you want to do with it, and then you send it to your database. And then from there, you go ahead and take a look at the database. So let's go back here, and where is the database? But in the schema.graphql. All right, this right here is the database of which this developer has extended an extensive database, and it has a lot of features. And I'm not going to go into all those features right now. You guys are smart enough to take all of this data, throw it into ChatGPT and say, hey, teach me about the mappings, teach me about the schema.graphql, teach me about the subgraph.yaml. And then from there, build up a baby subgraph and look at the difference, which is what we're going to be doing right now. We're going to build a baby subgraph and then come back to this and compare it to the advanced subgraph, both looking at the same smart contract. All right, let's go into some questions. One subgraph per smart contract? No. So you can have, let's flip that around. You could have as many smart contracts in one subgraph as you'd like. You could have 1,000 smart contracts as long as they're all on the same chain. If you have if you have all of your smart contracts on one chain, and say 1,000 smart contracts, they could all go into a single subgraph. But if you go to a different chain, that has to be a new subgraph itself. In account abstraction, okay, so the subgraph has to watch the blockchain and read the event when it's fired. Yes, so yeah, exactly. So you assign a subgraph to a specific chain, and then you find the smart contracts on that chain that you want to index, and the subgraph does the rest for you. Let's see. In account abstraction, there are a ton of smart contracts, one per user wallet. I'm not sure if that was a question. Looking at the event handle assigned language makes me think of Arweave's AO. Yep, there are similarities. There are absolute similarities. Great observation right there. So let's go ahead and build, guys. Let's do this. This will be quick. If you guys want to follow along, feel free. We'll start at thegraph.com. And we'll build this together. And this same flow works for any of the supported chains, including, of course, Rootstock. 70 plus networks, and there we are. So not only is it rootstock, but also the testnet too. So you can develop in a happy way. So something good to be aware of. So let's go ahead and start building. And we're going to go to Subgraph Studio. And, let's try that again. There we go. Okay. All right. So let's create a subgraph, and we'll say Rootstock CryptoPunks demo. Okay, we got that. And it's going to take us here. So this is Subgraph Studio. This is a studio where we can develop and we can iterate and we can test. This is completely free. This doesn't even count towards the 100,000 per month, because this is a developer environment. Nothing here is decentralized, by the way. This is a developer environment meant for iterating. It's rate limited. It's just meant to, meant for tinkering. The publish button, just a little fast forwarding. When your subgraph is iterated and got all the features you want, and you want to decentralize it and have it be in the marketplace, you click publish, and you publish it to the graph ecosystem, where all the indexers around the world can say, hey, do I want to index this? Do I not? That's where the tokenomic model comes in. We don't worry about that at all right now. We're just tinkering for free and having a good time. So if you haven't already, npm install Graph Protocol, Graph CLI, or Yarn, whatever you prefer. I've already installed, so I'm going to go ahead and initialize my subgraph. So I term, there we go. I'll make this one bigger. So, graph init. And then we have to decide, okay, which smart contract protocol do you want to go ahead and go through? So there's EVM compatible chains in here. There's mostly EVM compatible chains, which Rootstock is. And then also there's non-EVM, which is Near, Cosmos. Don't worry about substreams. That's a whole nother topic. And Arweave is, of course, non-EVM. However, we are in the EVM world because we are going to Ethereum mainnet. Have the subgraph slug pre-populate, whatever that is fine. Name the directory, it's fine. And then here's all the supported chains. And we know CryptoPunks is on mainnet. When you are looking at Rootstock, of course, you will just go ahead and scroll up to Rootstock and choose a smart contract on there. Same exact workflow. This is just a learning experience. So let's go ahead and go to mainnet. That's Ethereum mainnet. We'll do that. And then we have to find the contract address. So what I'll do is I'll go back here and I'll type in CryptoPunks smart contract address. There we go. And I think I'll just be better off. I know it ends in BBB, but just for the sake of, best practices, let's go ahead and look to see. There we go. CryptoPunks. There it is. Yep. Okay. Contract. Yep. CryptoPunks market. Feel free to run through there. Have a good time. And you say, hey, that's the exact smart contract that I would like. So copy right there. And then from there, now we're ready to just drop it in. That's all we have to do with the CLI. Let's pretend that this is your smart contract you guys just deployed, and just drop in, get the right chain, drop in the contract address, and now it's getting the ABI from Etherscan. Sometimes, just sometimes, could I increase the size of my pointer? Maybe next time. I don't know if I can do that right now. Sometimes the Etherscan is failing to find the start block or ABI. You can kind of see how it's being difficult like this. This is not us. It's not the graph. I wish the error message was more clear. This is Etherscan, rate limiting these attempts right here. So if you can't find it, that is okay. This is where the tool comes in. Miniscan.xyz is quite helpful at doing this. Just go to miniscan.xyz, and it has many chains supported, not all chains supported, unfortunately. We're trying to get this to be more part of our protocol, but this is the fastest way of being able to find the start block, and that's just helpful. So there are other ways that you could programmatically do it. You could write a little script with ethers, I believe, but in terms of just having it be in the browser, this is great. Also, it has the ABI. Sometimes the Block Explorer rate limits the ABI searching as well. Just know that Miniscan is out there, and that's quite nice. So let's keep on going. do I want to retry to find the start block? No. So I'll say no. Start block, I'll just drop that in right there, and we'll keep on going. The contract name is ideally you want to name it the same name as the smart contract that you're indexing, because if you're indexing 10 smart contracts, having good naming conventions is a good practice. And this is the magic. This is my favorite little button: index contract events as entities. This is taking one-to-one all the events that have ever happened since the very beginning of CryptoPunks and pushing them into a database, and in an organized way that we can go ahead and look at and send queries to in terms of timestamp, greater than, less than. We can really start to get into the data analytics and just kind of the mathematics of it. It's really cool. So this is the part I love the most. All done for you automatically. All that stuff I showed you before, it's all based off of a boilerplate CLI run. And it's truly something that I'm always impressed every time I do this. It's pretty dang cool. Okay, so do we want to add another contract? Nope, let's not do that. And then we can go ahead and continue on. We're free to run through this if you don't want to go back to the dashboard, but just for the sake of consistency, I'm going to go back to the dashboard that I was at earlier. And this authentication key is what you're going to want to have dropped into your terminal. I'm not going to do that because I'm already authenticated, and I don't like to show plain text off keys in the live workshop. So my computer is authenticated to this dashboard and my crypto wallet, so I don't have to do that again. And then I'm just going to go ahead and go right back down. So then I will enter the subgraph. I'll cd into the folder, and then graph codegen, that does the type safety, where it links all of the different files together in a nice way. And then build is the compiler. Let's not do that just yet, because what I want to do is code and just show you what this subgraph looks like before we go ahead and actually deploy this thing. So this is all local, of course. Nothing is running. We have a dashboard that is empty to review. This is still a draft. There's no indexing going on. We're quite sleepy. It's all good. But let's look at those three files that I looked at before: the subgraph.yaml, which is a high-level overview, the mappings, and there's only one file here because it's a baby subgraph. It's very small, and then the actual database. So if we have those three things, we have our subgraph. We are now in the subgraph.yaml. I'm not going to go through all these features. This is a great feature. If you're curious about it and want to learn more, go into the docs. I love this feature. It's awesome. But it's the same type of thing. We have the address. We have the start block where we want to start indexing. We have the entities that are in our database. We're just naming them. We're not doing anything beyond naming them. We're not showing the shape of how we're storing it. And then we have all the events that are coming from the chain, their event signature, and then the triggering of the handler that occurs every single event that goes through. And so let's just look at the punk transfer. Why not? It goes to the handle punk transfer. Let's look at the handle punk transfer. So anytime this event of the type transfer event is emitted from chain, this is triggered, and it passes this event data into this flow right here. So an entity is created, and this is almost the same with, this is the exact boilerplate you get with every single subgraph you spin up. So it's good to kind of learn this and kind of how this goes and kind of the shape of this. But yeah, so you get the event coming through. You create a new entity in the database, which is a new object in there. And you pass an ID into that new entity. And this entity is a concatenation between the transaction hash and the log index of the event itself. So this is automatically generated for every single entity in the database, and that's just really nice. You're free to change this to plain text. You could do whatever you want into that, or numbers, or whatever you'd like. It's best if it's in bytes, because bytes, of course, are much more performant. It's, in my opinion, just leave this as is. Don't really mess with the ID. It's just, it slows everything down if you have a string in there or something like that, or a number. Keep it bytes. And then you have the event, and here's all the different mentions of event all the way through here. You have the event signature information. You have the from, the to, and the value all being passed into the database. This is the entity. Entity means database. So entity from, the from goes right from the event, goes into the from the entity to the database. The to from the event goes into the to of the database. It's just literally pushing that data right in. No transformations are occurring whatsoever. And every single event, you get some more information, because every event has logs associated with it. Every event has a block, and if you look at the block number, every event has a block timestamp when that was eventually put in there, and which transaction hash actually triggered the event itself. So you could really get into some cool information just looking at the logs. So that is eventually, of course, the database saves that information. So this is all you got to know right here. This is really elegantly done in terms of the handle transfer. And if we go back to our buddy, this one, and we can see in this mappings, handle transfer, we can see this person has done a little bit more. Or we could see handle punk transfer event. This person has done much more. I mean, there's a lot of, you guys are developers, you know how extended things can be. It gets pretty beefy. If you want to think creatively about, okay, that transfer and this swap and this thing from an Oracle is coming in, and we're all pushing into the subgraph, and I've got off-chain data from an NFT, from IPFS or Arweave, and I'm all bringing it all in. And I mean, think creatively. It's pretty damn cool. Yes, the code is auto-generated. Great question. All of this is through the CLI. This is all the graph CLI. All I did was point the CLI, which it ran through here, to the smart contract, and I gave it a little bit more information, and from there just did everything. So this is very nice. And then once we're done with the transformations, which we haven't done any transformations, it's just all the boilerplate, it pushes it into the database. And this is the database. And so here, like I said, in the punk transfer, I think we're on the transfer, the punk transfer, one or the other. We have the from, we have the ID, which is bytes, which is great. The from, the to, and the value. So we're on the transfer. The from, the to, and the value. And then we also have the block number, block timestamp, and transaction rate. So this is all the information coming into the database. So this is the flow. To review once again, just to review the transfer. Transfer comes from chain, triggers the handle transfer event, and it goes, this is all boilerplate, goes into the transfer location of the database. Now, this is high-level overview in the subgraph.yaml. What does that actually look like? This is the handler. So when a transfer event comes from chain, an entity is created and given an ID that's automatically created. All of this is just passing data from the event into the database, of which is organized like this. And that's it, from high level, medium level to low level. Cool. So let's deploy this thing. Okay. We'll go here, close this, and all we have to do is graph code gen, graph build. Graph build. There we go. It runs through, does the type safety, and then does the compiling, and then we can deploy. So I copy this and drop it in. Graph deployed. Version label 0.0.1. Good December. Excuse me. And here we have. All right, build completed, deployed. All right, so as we can see here, it's in Studio. It's not in the Graph Network. It is just in my own little studio, and has the name, and here's my endpoint, and we're ready to go, which is great. So let's go back to the dashboard, of which I authenticated, and we can see, boom, already synced. Now, that's awesome, because it was that easy to do the CLI. We're now able to go to the playground, where we can send some queries and start to design some sexy queries and start to think creatively on these queries. Like, hey, do we want to look at not transfers, but let's look at the punk transfers, the first 10. Let's get their ID. Let's see here, they're to and from. And I want the punk index, like what punk it was. And I want to have it, let's see, order by. Let's see, do we have, I want the timestamp in there. So let's order by the block timestamp, because I want to know when, let's say the first 10 of all time, right? So let's go look at the first 10. Order direction is going to be ascending. So it's going to be lowest. So here we go. So now we have the first 10. This is a nicely designed query for the first 10 of all time, first 10 transfers of all time in the history of CryptoPunks. And I just clicked around and designed that query. So now, do I want to look at all this historical data? Here it is. That's the example. I could take this query, and then I can go ahead and send it to the endpoint right here, which is endpoints. There we are. So I have that query designed, and I can send it right over. So that is the overview of using subgraphs and building a subgraph and having a playground to query with. You have a history of all the queries you've ever sent. You can favorite queries, which I do like to do sometimes, which is nice. And you can go through all of these and really, really learn. One pro tip for those that are wanting to understand subgraphs better, if you have a subgraph, let's go back to the Explorer. And I want to go back to chunks. There we are. And here we have it. And let's go about and GitHub. If you are just wanting to query a subgraph and you're getting all those entities and you're like, I'm not sure what's in the database and how that is done, go to the schema if they provide it and look for the comments, because a lot of times it's just in plain English. Like if I send a query to the account entity, to the account, what's a weird word? That would not make sense if you were just like a punk. I don't know. Where would be a good one? Where would be a good one? Let's see. Anyways, there's comments in here. So it's like plain English describing things that is very nice. So look for comments. That's always a nice thing that Subgraph developers do, that you don't have to go into the code deeper unless you want to audit it and make sure they're doing it correctly. So that's important. So I think is this aggregated from events or is this local? Is this a local storage? I'm not sure. Oh, let's read it. Then we have additional storage for the query, a mapping of an address and all of its tokens. So yeah, I mean, if that is on-chain information, absolutely, that's absolutely possible. So if you're able to get if that information is stored in an event on there, go for it. Have fun. Yep. And then from there, you can dive in to see all the different transfers and create a different entity, like create a custom entity in your database and says this is the account entity. And every single time a transfer occurs, you're going to get a to and a from. And then so you have two account addresses right there. And then so the from is going to be someone that's interacting with the protocol for sure. And then from there, you know what I mean? You can start to deduce how to go from there to see who's actually interacting with the smart contract and play around. Is this aggregated from the events or is it local storage? This is all when you are on this subgraph. I'm not sure if this answers your question. This indexing is all done on the graph. You are not touching it. This is not done locally. This dashboard does not connect to my hard drive at all. This is done right now centralized because I haven't published this. This is not published to the graph network of indexers around the world. This endpoint, as you can see, goes to api.studio.graph. When it goes to the graph network, you'll see gateway, and that means it goes to the entire network. And then here, whenever your subgraph is ready to go ahead and be decentralized and not rate limited anymore and competitively marketed out there, you can go ahead and publish your subgraph. Excuse me. And you can signal on the subgraph, essentially putting some GRT on the subgraph to incentivize indexers to work. The more GRT gets on to the subgraph, the more likely you're going to have 2, 3, 5, 10 indexers hopping in and indexing the subgraph. And it's a marketplace, so sometimes 1,000 GRT will get 2 indexers on there. Sometimes you'll need 2,000 or 3,000 GRT to get multiple indexers on there. And yeah, so for the most part, publish, think production. Now this is where production is. All of this is free in this area. So just for iterating and testing and different versioning and all of that. So we've got about 10 minutes left here. And I'm happy to hang around and answer any questions that anybody might have. So yeah.
Amazing. Thank you so much, Marcus. That was a fabulously well done presentation and workshop. Yeah, as Marcus said, we do have a little bit more time if people have any questions in the chat. But also you've been great at answering as we've gone along. So no pressure if no one has any questions. If you do, just pop them in the chat now. I will edit and upload the video tomorrow, so you guys will have access to this tomorrow. I think we have a question there from Jumaru.
Let's see, Juma. And I just dropped my Twitter in there. If anybody has any questions, let's say in a week or two when they're developing subgraphs, just send me a message, and I'm happy to help out there. Let's see. What kind of database? Postgres. It's a Postgres database in the node. Good question. Can I share the dev Discord for the graph? Yeah, you bet. The graph is quite. I'm gonna stop my stream. How do I stop my stream? I'll figure this out here. Multiple windows. This is fun. Okay, cool. So let's go to my Discord, and I'll drop that in there. And the slides. Great. Guys, you guys are keeping me on track. Thank you so much. Right now, so much is happening.
Yes, I will
All
also
right.
send the slides in our Discord as well and in the YouTube description of the recording. So that will be easily accessible to all of you as well.
So yeah, I'll share that. I'll drop that in the chat. Is that okay, Adriana? Where I can just drop them in the chat and you get the link there? Okay, cool.
That's perfect.
So that's that. And yes, absolutely ask questions in the Discord. That is absolutely worth doing. My Discord is of course downloading an update, which means that's the way it goes. And so it's not loading. Let me find another way to get that Discord link. Graph.com. I think it's at the bottom of the graph.com. Somewhere there. Address and yep, that's it. Okay, so awesome. Yeah, get involved. The community in the Discord is super active. There's indexers, there's subgraph developers. If you need more data than events, feel free to reach out to substreams. That's a whole nother different way of building and indexing data. And I didn't go over substreams whatsoever at all, but if you are looking to get more raw blockchain data, absolutely. Are the size limits on results of a query? 1,000. Before you have to implement polling, you'll get 1,000 data points. And after that, you can run polling. Graph Client automatically has polling integrated. There's a few other different libraries that do that. So yeah, polling we're a big fan of, but yeah, we limit to 1,000 pieces of data coming back. Good question.
Any other questions from anyone else? Well, like Marcus said, feel free to drop him a message on Twitter or in the Discord. I'm sure you'll be able to answer your questions through that. Oh, another question. Here we
go. Yeah, I mean, once the data is in your possession, you are free to do whatever you like with it. And so get the return data from that query and store it in any way that you'd like. And then from there, you can go ahead and put it on Arweave for permanent storage. That's totally fine. And also Graph Node is open source. If you want to actually just store the data in your own Graph Node and send the subgraph to your own graph node, that's another way. Of course, that's centralized and that's not part of the graph network, but it is open source and you're able to do that and just have the data stored locally that way through a Postgres database. That's possible.
Great. Yeah. Perfect. Any others? Yeah, it was a great presentation. Thank you so much, Marcus.
Hopefully that was simple enough because it can get quite complex.
No, it was perfect. Yeah, so I think that's probably us for today. Again, feel free to reach out to Marcus on the mediums that he sent. Thank you everyone for joining today. Thank you, Marcus, for your workshop. It was great, super informative. And we'll be continuing this Educate series next week. So I hope you guys all have a great rest of your day and the rest of your week. Marcus, thank you again. And I will see you all very soon. Thank you.
Take care, everybody.